My dear students, now we are going to look at 4-bit synchronous down counter design. In this design, we will first look at the number of flip-flops required, and then followed by type of the flip-flop that we would like to use. Then followed by we'll go for the actual state diagram. Then followed by excitation table. Then getting expression for the flip-flop inputs. Okay, so it's a synchronous counter. Synchronous counter means clock is same, clock is common. So what we are trying to look is the 2 power n should be greater than or equals to capital N, where capital N is number of mod number. Now this is mod 16 counter. Okay, n is equals to 16. So 2 power 4 should be greater than or equals to 16. N is equals to 4. So we need 4 flip-flops. This is step 1. Step 2, as usual, T flip-flop we are looking for. So we will look at the state diagram. We have seen the state diagram for up counter. So it's the same. So what I try to do is I have to draw with a larger dia. Okay. Similarly, okay. So if I do this, then for 1111, next state is 1110. Okay. For this, what we try to do is here it will be 00000. Okay. So one down than this is 14. So what exactly 1001? So 1101, 1100. Okay, likewise we need to go and decrease it. Okay, so it will be 00001, 0010, 0011, 0100, 0101, 0110, 0111. So and then 1000, 1001, 1010, 1011. So from this present state, it will go to this next state. This is the 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 next state. Right? This is the next state. 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 From this information itself, we will build the table. Okay, from where to where we are moving and what is the present state and what is the next state. So this is known as the state diagram for what exactly it is 4-bit synchronous down counter. From this, the rest is excitation table development. So the excitation table for what exactly it is? Excitation table for the counter. For the counter. Which counter it is? 4-bit synchronous okay, down counter. Okay. So what we try to do is we will look at what exactly the present state and next state. So here it is present state. We are going to the next state. So this is QA, this is QB, this is QC and QD. This is QA plus 1, QB plus 1, QC plus 1, QD plus 1. Okay. Now we are going to inputs for TA, TB, TC and TD. Now when the input is 0, output is 111. When it is 1, it will be 0. So 1 down. Okay. Next it is 1 less than the present state. Okay, because it is a down counter. So let us observe 0 1 1 0, 0 1 1 0. It continues for all the cases. So simply by observing, I can say that TA is always 1. So I am entering the values of TA. Once you enter the values of TA, look for T, B and TC. For that, what I need to do is I need to compare. So we will make a comparison here. So this is 0 and this is 1. So what exactly we'll get is 1. As we know, Qn plus 1 and T. 0 0 is 0, 0 1 is 1, 1 0 is 1, 1 1 is 0. This is excitation table for T flip-flop. So from that we are trying to get, because we are using T flip-flops. Then if you look at this 0 and this is also 0, so 0. Whereas this is 1 and this is 0, so this is 1. And whereas this is 1 and this is exactly 1, so it is 0. Now if you look at this is 0 and this is 1, so it is 1. So from simple observation I can say that it is continuously giving us 1 0 1 0 1 0 1 0. If you want to check it, you can check it. Okay, 1 0. See, for example, here you can compare. Okay, what exactly we are comparing? So this is compared with this one. Okay, okay. So what we are trying to get is, this is what exactly we are comparing, not this one. This is TA. So we are comparing this one with this one. This is first 4 inputs. First 4 is present state. Next 4 is next state. Okay. So when we compare 1 1, so output is 0. So this is what exactly we have it. Next we will look at QC and QC plus 1. If you observe here, 4 zeros, and whereas this is 1 followed by 3 zeros. For 0 1, this is 1. For next 3 zeros, 3 zeros same. So 0 0 0. Next, a couple of things that you can observe here. Next I have 4 ones. Next I have 4 ones. Here I have 0 followed by 3 ones. If I make that into consideration, then it will be 1 followed by 3 zeros. So it applies for rest of the cases, 1 followed by 3 zeros. Now if you look at the other case, that is QD, this is 0 and this QD plus 1 is 1. So it is 1. For the rest of the cases, there's 7 cases. So it is always 0, and this is also 0 till here. So what I try to do is, still there I will write as zeros. Okay, totally 7 zeros. Next, if I look for 1, okay, and it is 0, so it is 1. For rest of the ones, if I look at it, here these are all ones, here these are all ones. So I can make this zeros, right? From this, what I can do is I can write expression for what exactly known as TA, TB, TC and TD. TA is 1 for everything. So all min terms, sigma m, all min terms, all min terms. What about TB? What about TC? And what about TD? TD is only 2 values. What are they? It is 1 for 0 and 1 for 8. Sigma m 0, 8. TC, it is 0, then that is 4. So 0, 4, right? Is it 4 or 3? Just look at it. The TB is not TC. So 0, 1, 2, 3, 4. So 0, 4. Then will be 1 for what exactly? This is 8. So 8, 12, okay. 0, 4, 8. Only 4 terms. Okay. So these are the min terms. This is, I can say, TC is sigma m, TC is sigma m, TC is nothing but sigma m of these values. Similarly, TB, if I look at the TB, sigma m TB, okay, sigma m, what I need to do is, I'll take TB, then I try to show that TB is sigma m. What are the values? It is 1 for 0, then it is 1 for 2, 4, 6, 8, 10, okay, 12 and 14. Okay. So once we know this, then just we use K-maps and then try to do it. So TA part, this is your, let's say, is your QA, QB, QC, QD, 1 1 1 1 1 1 1 1, okay, 1 1 1 1 1 1 1 1, all are ones. When all are ones, TA is 1. Okay, next we are looking for TB. So this is QA, QB, QC, QD, right? So what I need to do is something like this. That is what exactly expressions I got. I got is it is for 0 it is 1, for 2 it is 1, for 4 it is 1, for 6 it is 1, for 7 it is 1, for 8 it is 1, for 10 it is 1, for 10 it is 1, for 12 it is 1, for 14 it is 1, right? So can I combine like this? I can combine like this. If I combine it, then I'm going to get the expression for TB turns out to be, okay, what is that? It is there is QA bar. Okay. Next, if you look for TC, expression for TC, it is 0, 4, 8, 12. So 0 is 1, 4 is 1, 8 is 1, 12 is 1. So if I combine this 4, the expression for this will be for TC, which is nothing but QA bar, QB bar, right? Next, if I go for TD, which is 1 for 0 and 8. So for 0 it is 1, for 8 it is 1, this is QA, this is QB, this is QC. So if that is the case, then what I can do is I can combine like this. If that is the case, the expression for this will be TD is nothing but what is this QA bar, QB bar, and what I have is QC bar. So it is QC bar, QB bar, and QA bar. Okay. Once you got the expressions, so we will collect all the expressions at one place. TB is QA bar, this is QB bar, and QA bar. Okay. So what about like this? This is exactly is your QC bar, QB bar, and QA bar. This is for 4-bit down. If you make it as a 5-bit down counter, the extra we are going to get a TE. Okay, so the TE will be is your QD bar, QC bar, QB bar, and QA bar. That's all. Same procedure. Okay, this is exactly when we are dealing with 5-bit synchronous down counter extra expression that we are going to get. Okay, up till here is 4-bit. Okay, if you add this expression, that will be 5-bit synchronous, okay, down counter. Is that fine? So the rest of the steps are same, whether it is 4-bit or 5-bit. Okay, so next is just draw the circuit diagram. So you can draw the circuit diagram, right? So very simple. There are 4 flip-flops. Okay, so flip-flop A, flip-flop B, flip-flop C, and flip-flop D. Accordingly, we are going to put the inputs for them, then we are going to work. There is a common clock, of course. Clock is common here, common here, common here. We will represent the flip-flops. This is flip-flop D, flip-flop C, flip-flop B, flip-flop A, QA, QA bar, QA, QA bar, QB, QB bar, QC, QC bar, QD, QD bar. Okay. So this is a TA, which is always 1 connected to 1. This is TA. TB is connected to QA bar. So this is connected to QA bar. Whereas this is connected to QA bar and QB bar. So the input is like this. There is an AND gate. One of the input is QA bar, another input is QB bar. That we are giving it to TC. For TD, this is TD. I take 3 input AND gate. another input is QA bar, another input is QB bar, another input is QC bar. At output I am giving it to DT. Okay, this is the clock. This is synchronous 4-bit down counter. Done.